In the name of Allah, the most beneficent and the most merciful. My name is Aisha Rafiq and I am student of BS Chemistry. The course instructor is Ma'am Sadaf Javed from the University of Central Punjab. Today I am going to discuss stereoisomerism as a project presentation. Let's move toward the content list. First of all, we have introduction to the stereoisomers. Then we have types of stereoisomers. There are two types of stereoisomers. First one, optical stereoisomer, and the second one is geometric stereoisomers. Then we have some example of stereoisomer, and after this we will discuss the importance of stereoisomers, how stereoisomers react with the living systems, and what is the role of stereoisomer in the pharmaceutical medicines and drugs. After this we will discuss optically active compound, what is chirality, and which compounds are called chiral compounds. Now let's start. Stereoisomers. Stereoisomers are isomers in which have same molecular formula, same functional group, but differ in the way the atoms are oriented in the three dimension. Type of stereoisomers. There are two types of stereoisomers: geometric isomers and optical isomers. Geometric isomers have same structure formula but differ in the arrangement of group, atom and bound rings. They have completely different physical and chemical properties. For example, if we have any compound in the form of cis and trans are the good example of the geometric isomers. If we talk about the optical isomers are two compounds which have same structure formula but different spatial arrangement of atoms. They are non-superimposable mirror image. They also have differ in only one characteristic, which is that their interaction with the plane polarized light. For example, amino acids are the good example of molecules, and they are also a good optical isomers. In this picture, we have two types of butene. First one is trans 2-butene and the second one cis-2-butene. In trans, we see that the methyl group attaches to the carbon number 2 and 3 on the same side, whereas in cis-2-butene we have two methyl group but on the two opposite side of the carbon 2 and 3. In this picture we can see that both are the structure of alanine, but both of them are mirror image of amino acid alanine. They are also called optical stereoisomers. In this picture, the interaction of optical isomers with the polarized light. The plane light fall on the compounds which are stereoisomers and reflect into different way, which may be left side or right side after passing from the filter paper. Next one, why stereoisomerism is important. Stereoisomerism is important because of its mirror image quality or enantiomerism. First one is importance is that interaction with the living system. Enantiomer basically called mirror images. When two enantiomers interact differently with the one or more smell receptors proteins in your nose and generating the transmission of the different chemical signals to the olfactory center of your brain. The most famous example is the Chinese traditional medicine, which is stimulant and appetite suppressant. You can see the structure formula of the two active ingredients which is used as nasal decongestant. The second one is our ability to taste and smell is regulated by the chiral molecules in our mouth and nose. Chiral molecules act as a receptor to send foreign substance. We can anticipate that enantiomers may interact differently with the receptor molecule and induce different sensation. For example, the two of caravans have one of them have a odor of caraway and the other of spearmint. Both are the mirror images of the caravans. They are also called the enantiomers of caravans. Pheromones. The chemical substances that affect the organism behavior are called pheromones. Some animals and insect rely on what amount to be a sense of smell for the communication with the other of their species. The famous example of pheromones is Bombyx mori. The sex attractant of silkworm moth Bombyx mori has been identified for its pheromones. The given below formula is Bombyx mori pheromone. The role of stereoisomer in pharmaceutical production and the breaking down of drugs in the body. Most drugs are often composed of a single stereoisomer of a compound, while one stereoisomer may have a positive effect on the body and the other may have a negative effect. The famous example of this point is that the thalidomide crisis in 1950 and 60 shows this well. When the thalidomide prescribed as a sleeping pills to lessen the effect of morning sickness in the pregnant woman, but as a result it causes a birth defect in the child because it contains racemic mixture. Racemic mixture at a mixture in which we contain 50 by 50 both mirror images of one stereoisomer, due to which one causes positive effect on the body and the other one causes negative effect on the body. This shows that the both of them combination causes both positive and negative effect on the human body. Now we will just discuss optically active compound. A compound capable of optical rotation is said to be optically active. All pure chiral compounds are optically active. If a lactic acid is chiral and rotate the plane of plane polarized light, thus one lactic acid is optically active. What is chirality? Chirality is the property of molecule that result from its structure. Chirality is necessary condition for existence of enantiomers. What makes a compound chiral? First one, it must be sp3 hybridized. Second one is that have 4 different group attached to the central atom. Third one is that not be a superimposible on its mirrored image. It means that not be lie down on each other. Chiral compound, a compound that contains asymmetrical center with chiral center, which may be also called asymmetrical center or chiral center. Chiral compound has a mirror image. They are also non-superimposible mirror image, which means that a chiral molecule cannot be lined up with it perfectly. This pair of non-superimposible mirror images molecules are called enantiomers. Example of chiral drugs used in anesthesia are ketamine, thiopentone, and isoforan. It's all about the stereoisomers, chirality, chiral compound, and its type. Thank you so much.